Today marks the day of the 47th and the start of a new era with Mr. Schroeder leading the way. This is the first mission that Mr. Schroeder is leading, which differs from previous missions that Mr. Rutledge led. As a reflection of some current events in the aerospace world, we're going to Mars. We're going there to take ground samples and atmospheric samples using a custom-built rover. The results of this test should determine what the surface is made of and what the atmosphere is made of, and it might help us find life on Mars. This is a very important step in human evolution to discover new planets, and I think that simulating it here today is very important. We have an amazing team this year that has been working hard since January to make this happen. Everyone you see behind you and next to you has been a crucial part of the mission. We could not have done it without them. Please give a round of applause to Mission Control. Some of the most important roles in this mission include all of our chiefs and our two other directors, John Walgast and Ryan Kimball. Each team is so crucial that I think it's important to name the contributions of each team to this mission. I'll start with the geology team. The geology team really stood out to me. They picked a spot for us to land and designed the Martian ground and experiments to test on Martian rocks. They have been working very hard to design a specific experiment that will yield specific results if done right. The mechanical engineering team has engineered a robot to collect samples and a satellite catching system to retrieve and deploy satellites from the space shuttle. They have programmed and built the rover to do specific tasks. The electrical engineering team has engineered some thoughtful disasters using electrical kits and has taught the astronauts how to solder and how circuit boards work. The shuttle engineering team has prepared our shuttle for launch by redoing the cockpit, doing the well-needed cleaning job, and installing foam head bumps. Thank you. And stocking the shuttle to the astronauts. The communications team has been working really hard to set up cameras and microphones to the shuttle and mission control. Has written the ascent and descent scripts with the help of some other groups, and has been the commander on all walkie-talkie situations, which is crucial that we talk to the astronauts and mission control. The public relations and art team has been making a movie for the mission, has been making badges, and has been making the iconic mission board for Mission 47, which will happen during the mission. They have also created custom t-shirts for everyone at WAVE. The security and hospitality team has been sending letters out to elementary schools and has been regulating Weber Space Center in regards to people entering in and out and all security-related issues. The astronauts have been training long and hard for their mission by doing things such as their physical exercises like push-ups, planks, and runs, their science experiment prep, their medical recordings, their geology, electrical engineering, mechanical engineering, shuttle engineering, and communication skills for the mission. They've been regulated by their astronaut trainer, who is vital to getting the astronauts ready and prepared. And finally, satellite engineering has been making different systems to set a satellite up using a quote-unquote rocket system, using a pulley and ropes, and which carries the satellite up, which will then be retrieved by the robot arm. And now the people that made this all happen, I'd like to thank Mr. Schroeder and the alumni.
Okay, so for our Mission 47 to Mars, over here, we have Lauren Sampson, the astronaut trainer, Alessandro Clef, the alternate astronaut.
Start off, Ryan Owens for the mechanical engineering team.
Yes.
So on my team, I have Tim, Andrew, Joaquin, and Dylan. And
Then can you guys raise your hands so that I can see you? Thank you.
Alright. Next is Trevor Kirk on the electrical engineering team.
I have my team is Morgan and Matthew.
So what'll happen next, folks, is we'll give the students a couple minutes to get in position. We're gonna go through our simulated launch. That'll probably happen in just a couple minutes. Waivers, please find a place distributed throughout the room where you're not, kind of on top of each other.
Okay, so after everyone gets settled, we're gonna turn the lights out for this. But
They are.
this presentation. Also, most of us should have lights, so you will see.
Yeah. Is that what Ryan wants to do eventually? Yeah, that's awesome.
I'll go look around.
Wait, no. Astronauts, do you copy? Astronauts, do you copy? Okay, so we're gonna do a countdown. Start the timer. Wait, does everyone here have their timer set to 10 minutes? We're gonna do a countdown and you all press it at the same time so we're synced. Alright, astronauts, we're starting the timer countdown. 3, 2, 1, start. Space Shuttle Odyssey, this is Mission Control. Do you copy? Over. Mission Control, we copy. Over. Odyssey, begin pre-flight procedures. Over. Control, we are beginning pre-flight procedure. Out. Odyssey, this is Mission Control. This is an external radio check. How do you copy? Over. Mission Control, we copy loud and clear. How do you copy? Over. Odyssey, we copy loud and clear. Out. Odyssey, this is Mission Control. Confirm all required equipment and supplies are loaded and secure. Over. Mission Control, all required equipment and supplies have been loaded and are secured. Out. Odyssey, this is Mission Control. Turn off fuel and oxygen transfers. Over.
engineering.
No.
Electrical engineering.
No.
Odyssey, this is Mission Control. You're to go for launch. Over. Roger, out. Odyssey, this is Mission Control. You're to go for auto sequence start on your onboard computer. Over. Roger, out. 12, 11, 10, 9, 8, 7. We maintain engine start. 5, 4, 3, 2, 1, 0. SRB ignition. We have liftoff. Odyssey, this is Mission Control. Your engines are now throttling down to 65% power. Over. Set out. All 3 engines are back at full throttle. Odyssey is now 8 miles downrange at an altitude of 14 miles. Approaching 1 minute 50 seconds into the flight. Standing by for pull and separation of solid rocket boosters. SRB on the orbiter. Odyssey has burned more than 2 tons of fuel and weighs half of what it did at launch. Activate Star Tracker systems. Over. Activating Star Tracker systems. Out. Odyssey, this is Mission Control. Initialize SRB separation. Over. Separation is on. Out. Odyssey, this is Mission Control. Activate SRB separation. Over. Separation successful. Out. Odyssey, this is Mission Control. You're go for throttle up. Over. Roger. Go for throttle up. Over. Odyssey, you have 3 good engines operating at 100% power. Over. Roger. Out. Odyssey's altitude is now 75 kilometers. Odyssey will no longer return to Weather Space Center in the event of an engine failure, but all 3 engines are doing very well.
Okay. So, way to solve this is
This is an actual disaster that we didn't plan.